In this video, you're going to be learning how to solve when you have fractions. So we're going to have to first make sure that the fractions have the same denominator. So again, the first step is we need to get the same denominator. To do that, we're going to multiply each fraction by something to make the same denominator. So in this case, the 3x squared is the thing we're trying to get to because this one's already x squared. This one's x. So the x squared fraction, we could multiply top and bottom by 3. And this other fraction, the 3 over x, we could multiply it by a 3x. Once we've multiplied those, we now have a 9x over 3x squared. We have a 6 over 3x squared. And that gives us 7 over 3x squared. Now, if I took and multiplied both sides by a 3x squared, or I could combine these fractions first if that helps, I have a 9x plus 6 over 3x squared, and that equals 7 over 3x squared. Now, I could take and multiply both sides of my equation by a 3x squared. That's going to reduce out the 3x squareds on both sides. But we do have to make sure that we don't get an answer of 0 when we solve the rest. Because if we did get an answer of 0, that would make 3 times 0 squared on the bottom of a fraction, which would be 0, and you cannot divide by 0. It's undefined. So we have to make sure that the bottom of our fraction does not equal 0, and then we can solve the rest. So now we've got 9x plus 6 equals 7. I'm going to subtract 6 from both sides, which gives me an answer of 9x equals 1. Then I can divide both sides by 9, and I get x equals 1/9. Now I checked my answer 1/9. I check it up here. It does not match with the 0, so this answer is fine. It checks out. So going back to this, writing down the steps, we got the same denominator. The second thing we did was combine fractions. The third thing we did was multiply by the denominator. After we multiplied by the denominator, we made sure we named this thing that x cannot be. These are called the excluded values. Last thing we did is we solved for x. And then we just check to make sure that it doesn't match the excluded values. So we're going to do those same steps on the next problem. First thing we want to do is get the same denominator. To do that, we need to factor this one on the right. We'll multiply as a 2 and adds to 3. That would be a 2 and a 1, using both negative to make -3. So notice that this fraction on the right already has both factors or both denominators of these two other fractions. So we need to match these two other fractions with this one on the right, which means that I need an x minus 2 on the first fraction, and I need an x minus 1 on the second fraction. This makes my fraction x minus 2 over x minus 2 times x minus 1. And I'm adding to that a 2x minus 2 over an x minus 2 and an x minus 1. And that equals 3 over x minus 2 and x minus 1. Now we combine these fractions together, which was our next step. Combine these fractions and I get 3x minus 4, and that's over an x minus 2 and an x minus 1. And that equals a 3 over an x minus 2 and an x minus 1. Next thing I want to do is multiply by the fraction, by the denominator. So if I multiply both sides by an x minus 2 and an x minus 1, these will eliminate the denominator. And I can do that as long as x does not equal, so this parenthesis, I can't use a 2 because that would make 0 times 1, and that doesn't, you can't divide by 0. And for this other parenthesis, I can't use a 1 because that would make negative 1 times 0, and that would be dividing by 0 again. So that was step 4, the excluded values. Now we have step 5, we're going to solve what's left. And we have a 3x minus 3, or 3x minus 4 is equal to 3. Now I'm going to add the 4 to both sides. And I got 3x equals 7. Dividing, I get x equals 7/3. I check that with my excluded values. They do not match, which means this is my answer. It checks out. So that was step 6. Are they excluded? When you run into an excluded value, say for example, if we would have got x equals 2, and we say that it can't be 2, we would cross this out and call it an extraneous solution.